Hey everybody, this is Tech Teach again. This is lesson 2 of the electrical circuit simulation program. The activity that we're looking at is found in your Moodle site, and I would like for you to read the first page. Then I would like for you to click on and load the circuit simulator kit or the circuit construction kit from Colorado. And once you do that and you've looked at the symbols and you understand the symbols, these are the symbols. If you click on symbols in the program, it'll show you these symbols, and this is what they mean. And these are wires and resistors and batteries and those kinds of things. These are like pictorial views of the same thing. So after you finish reading this, you're going to see Ohm's law right here, and you need to understand that this is the formula that we're going to be using. I stands for current, voltage is V, resistance is R, and I is equal to voltage divided by resistance. An amp is equal to a volt divided by an ohm. Ohm is a measurement of resistance. Amp is a measurement of current, and volts are a measurement of voltage. So here's a classic example of a circuit. This one is a parallel circuit. So we have one loop of electricity going here, another loop of electricity going there. So that is a parallel circuit. And these are amp meters. So this will tell you how much amperage is going across the circuit. So let's do number 1 together, and then you can do the rest of them on your own. Number 1 is saying, on a camping trip, you decide to use a cordless air pump to inflate an inflatable mattress. If the air pump is powered by a 9-volt battery with a resistance of 18 ohms, what is the amount of current flowing through this circuit? So in order to do this, we're going to flip over to our construction kit, and I have prepared for us a simulated air pump circuit. So we have a 9-volt battery. It flows and it goes through a 18 ohm resistor. Then I put an ammeter. See that check right there? Adds the ammeter to the toolkit. And I put the ammeter in the circuit. And it goes around to the switch. The switch is off right now. Then it goes around, and the only thing that this thing has is a light bulb, but the light bulb is going to have to be set to whatever it tells you it's supposed to be set at. So if the air pump is powered by a 9-volt battery with a resistance of 18 ohms, what is the total amount of current flowing? So I guess what I need to do here is I need to take the resistance value down to 0, because I've got 18 volts here, I've got 0 here. So you just need to set up the situation here. Now as I move my switch and close the circuit, the electricity, the electrons are flowing in a counterclockwise motion, and I have 0.5 amps. So if you set this up, you should be able to use the Ohm's law formula of, let me go back to it. Yeah, the Ohm's law formula, current is equal to the voltage divided by the resistance. So it says right here that we have 9 volts and we have 18 ohms of resistance. So the current is 9 over 18, or 1/2, or 0.5. So you'll draw a schematic similar to the one up here of the circuit that you just made in this circuitry program, and then you will put I equals V over R right here, and then you'll put the numbers in for it and calculate the final answer. So go ahead and complete the activity. There are 3 and then some questions creating a parallel circuit and those kinds of things. So there are 3 or 4 pages here that you're going to have to do. And then it ends up with a combination circuit and then some conclusion questions right here. So good luck getting that done. Please do it. You can use Word to finish it or whatever you want, and then turn it in to me or email it to me.